Hi, I'm Ryan Nickel, CTO of DSA, and today I want to show you how to make some flotation for your oceanographic moorings using the ExtMass feature. So in Proteus, you can add all kinds of models for loading effects using features. What we're going to do is work with the subsurface mooring template. So go to New Project from Template, Quasi-Static Subsurface Mooring Template. And it'll give us a quasi-static cable to work with. But ExtMasses work with any of our cable models. We're going to make a brand new ExtMass feature. So if we go to Feature and then choose Feature Type ExtMass, and we're just going to call it Glass Float. You can call it whatever you want, depending on how specific you want to get. And you'll see the library open up and the new ExtMass options show up here. So we've got a few properties, and there's two ways you can specify the properties for an ExtMass. So it uses a reference sphere for the calculations. The default is you can specify the density and the diameter. It's a pretty simple way to do it, but it does kind of link the drag diameter with the buoyancy, and that can get complicated sometimes. Often we want to specify by ExtMass type 1. So if we change that to 1, you can right click on this and then resolve follower properties, and it handles adjusting some of the inputs here for you. Then what you need is the mass in air and then the equivalent weight in water. We're going to get that from a spec sheet that we're going to work with right now. So what I've got here is some Teledyne benthos glass spheres. And in this spec sheet there's two different kinds, two sizes, 13-inch and 17-inch. Now I've highlighted a few properties here. We want to work with the 17-inch. So you can see there's an outside diameter here, okay, and a weight in air, so that's the mass number we want in air, 17.7 kilograms, and then a net buoyancy, 25.4. Because it's flotation, that's going to mean a negative number when we put the weight in water here, and we're going to come right back to that in 1 second. But often glass spheres will have these hard hats as well, so this is some extra detail we can get into, and we'll look at that in 1 second. First off, let's look at the net buoyancy here, 25.4. Okay, so we go down here. Remember, a negative value indicates that it's buoyant, so we put in 25.4, negative there. And remember, this is a number of kilogram force, so the number is sort of the same as kilograms, and typically to make it easy to work with these spec sheets. Now, for the mass, let's go back to our spec sheet. We did see it says 17.7, but then I want to include this hard hat as well. Fortunately, the hard hats are neutrally buoyant, so it won't affect the weight in water, which is great. And you can see for this type of hard hat, the 204 SRM, that's the super ribbed version, it's got an extra mass of 3.74. So we'll put in 17.7. I'm just making some notes here. Oops, that should be 7.4. And I'm realizing I need to calculate all this. Damn, it's going so well. Oh, pause. We put in the total here, 21.4. And I just made a note here, glass sphere, hard hat. There we go. Now let's look back at the spec sheet again to pick an appropriate diameter. It looks like from the schematic here for the super ribbed, I'm just picking off one of the key dimensions here, A. That's probably a pretty good approximation, and it's 55.9 centimeters. There we go. And that's it. We've created our ExtMass. How do we apply it to our mooring? Well, you can right click, insert property, fluid loading, ExtMass. Then when you right click on the name, you can use existing feature, and there you can see is our glass float. This final number is just the arc length along the span where the glass float will be. So we can put it at 50 meters or wherever you want. And you can even put copy and paste as a text editor. You can put another one right on top of it or a little further down, whatever you like. So that's how you use ExtMasses. Thanks for watching.